This is another example of ROSLab for running a source code repository. We go to GitHub and look for the Vince Mono repository, which is the source code of a paper pre-published at ICRA 2018. This is a fork of the original repository where we have added a ROSLab definition file. In this file, we specify the ROS distribution, the building method, the NVIDIA runtime environment, a volume with the datasets, and the binary and source packages that we need to build the source code. We need to clone this repository into our local computer. So we copy the address of the repository and go to the terminal. We execute the git clone command with this address, so we download all the files in the repository. It takes a bit of time, but when everything is downloaded, we can run the script for building the Docker image of this repository. We launch the command. It will execute all the necessary steps. It takes a bit of time, so we accelerate the video. The source code is being built, all the making steps, and eventually all the steps will be completed and the Docker image will be ready for execution. Alright, that's it. So now we launch the running script for running JupyterLab in the Docker image. The JupyterLab is running, so we need to open a browser window, connect to the JupyterLab, and the README document will be shown in a notebook format. We can see all the information. We can skip all the installation steps because this has been already done in the Docker image, and we can move to the example. There are several commands here that we need to run in parallel. So first we split the cell in 3 lines. We will open 2 different notebook windows for running each ROS launch script. So the first one will be the Vince estimator Euro launch. We drag this code into the new window and we just launch this command. We open a new subwindow with another notebook for launching the second launch file, the visualization node. We drag the statement and launch it. And consequently, the RViz environment will open in our desktop. Finally, we need to launch the ROSBAck command. So we go back to the original notebook. We replace this dataset path with the real path of the back file and launch the ROSBAck play command. It starts to play the data and we switch to the RViz window where we can see that the images are shown in the RViz and also that the frame of the camera is moving accordingly in the 3D frame. You can see the correspondences between images, and this will go on for all the ROSBAck data. Since there is quite a lot of data, we speed it up a little bit with this acceleration. We can see all the trajectory of the robot, and finally it lands. We can go back to the JupyterLab notebook and see that the ROSBAck play command has been done completely. And we can also see the output of the other ROS launch commands. For example, the tracker, where we see the data that has been output to the screen. We can close the RViz windows. We go back to the JupyterLab browser. We can simply close the browser tab and it will close all the notebooks associated in that window. We just leave the site, go back to the terminal, and stop the script there. The Docker image will be stopped and everything will be finished.